给我放大。
拿出你的小黄蜂。
可以了。
是谁生气？
这不是我的。
其余东西都要收起来了，例如说像这个手机要收起来了。
好。
手机收起来。怎么有人现在才打开啦？Okay, let's turn to page 28. We talked about yesterday's experiment. Ticker tape timer. Ticker tape timer. 打点计时器 Okay? So let's grab it. Okay, this is the tape. And that's A, B, C, and D, right? And yesterday you worked on your worksheet, and first one you can use your ruler to measure the distance. This is called displacement. Wave displacement, okay? And second one we call it delta x2, delta x3, and the last one delta x4. Okay, and now yesterday in fact you can find that the displacement delta x2 minus delta x1 and delta x3 minus delta x2 and then blah blah blah. Their ratio is like 1, 3, 5, 7, blah blah blah. Okay. But now you don't have your worksheet. I will hand it back to you, okay? And we are going to prove they are equal to AT squared. Okay, that's on your page 28. 28. Okay, for our first one, how to calculate delta x2? How to calculate that? You still remember the three formulas? The three formulas. First one is B equals to B0 plus AT, right? In your junior high school, you still remember this formula? Okay, good. And second one is displacement equals to B0T plus 1 over 2 AT squared. And third one, which is without time. So B squared equals to B0 squared plus 2AX. You still remember? Okay, so now let's prove this one. For delta x2 here, if we name it delta t. So for delta x2, it's the total displacement minus this total displacement. So that is called delta x2, right? So I will insert into the second formula. So B0 is 0, okay? So I will insert 1 over 2 A T is 2 delta T, right? And the total displacement minus the first displacement equals to delta x2. Okay? Minus 1 over 2 A T squared. So what do you get? 1 over 2 A 3T squared. Right? This is the delta x2. How about delta x3? Delta x3. Here. And now you know that it's this displacement minus the previous displacement, right? So I will write 1 over 2a 3t squared minus 1 over 2a 2t squared. Okay? So now you get 9 minus 4, which is equal to 5t squared, right? So now I only write delta x2 and delta x3, and you can find the ratio. This is 3, and this is 5. Guess it. What's next? What's next? 7. Good job. And it's a ratio of 1, 3, 5, 7 to 1. Okay? Okay, please write down on your 28. 28. The block. Prove it, okay? So now I can use delta x3 minus delta x2. So I get this one minus this one. So 1 over 2a 2t squared. So I prove it. So for this one, since acceleration, 加速 is a constant, and delta t is also a constant, so this one equals to a constant, 定值, okay? And now let's turn to page 29. We are calculating the velocity of each dot, okay? Maybe you can calculate VB and we can calculate VC. That's what you've done yesterday, right? For VB, how do we calculate that? So remember, we use delta x over delta t, right? So for VB, how to calculate delta x? In fact, VB is the average velocity, 平均速度, average velocity between the point A and C, right? Because B is at the middle of the time. At the middle of the time, its velocity equals to the average of A to C, okay? So I write delta x over delta t. So here, delta x1 plus delta x2 over the total time to delta t. Understand that? Yes. Okay. I think I will leave it for you, okay? Just insert it. And for VC, the same thing. It's also a displacement over the time. So VC, that's it. It's the average velocity between D and D. So delta x over delta t. So delta x2 plus delta x3 over 2 delta t. That's it. And that's the second step you've done yesterday. And the last step, we are going to find the acceleration, right? So yesterday, how do you calculate the acceleration? You use the definition, right? over delta t. So you get final velocity minus initial velocity, so vc minus vb, over the time between these 2 points. A question for you. This one, I should write delta t or 2 delta t. See the graph there? Between VB and VC, what is the time interval? 1 or 2 delta t? B and C. What's the time interval? 1. Good job. 1 delta t. So that's the method we used yesterday. Okay? You can write that on your 29. And now it's time to do the practice. Example 1. example 1, I want you to share how you deal with this problem with your partner beside you, okay? you have already tried your best, right? I'm going to talk about it. Okay, by the way, if this delta is a constant, what kind of sequence is this? Your homeroom teacher have told you. If delta x1, delta x2, delta x3, delta x4, and their deviation, their difference, in Chinese we call it cha. Okay. They have equidistance. So what kind of sequence is this? 等差数列, right? Okay, so you can use this concept. They are equidistant because it is a constant. So you can use this concept to solve problem 1. What is the position of D, right? What is the position of D? You can use this concept, okay? Let's do that together, okay? First one, it tells us that this position is 9 centimeters. That B, the position is 13, and C is 29. So let's derive its displacement, okay? So between 9 and 13, its delta x is 4, right? And between 13 and 29, what's the difference? 16, right? So this one is 16. So I told you that it's equal distance, right? So 4, 16, what's next? 等差数列4 16 what's next? 28, 很棒 28, right? 28. So what is the position of D? Now you derive it, right? So the D position equals to original 29 plus the delta x, which is 29 plus 28 equals to 57. So that is the position of D, okay? And then maybe you can give yourself a hint, 等差数列, okay? Okay, let's see number 2. What is the acceleration? Yesterday we've done that, okay? What is the acceleration of this tape? What is the acceleration? So we have to calculate the B velocity. And the second step, let's calculate VC. And then delta V over delta T. That is the acceleration, okay? So now let's do that together. VC minus VB over the delta T between them. Okay. First, the easier one. What is the delta T between B and C? What's it? Yeah, 1 over 10. How do you know that? Because the frequency is 10, right? So now the period, which is the time between them, that is the reciprocal 导数 of frequency. So it's 1 over 10. Good job. So we can write 1 over 10 seconds. Then, how do we calculate VC? How do we calculate VB? Then let's do that, okay? VC, we have to calculate the average velocity between B and D, right? The average velocity. So we use 16 plus 28 over the time between them. Again, what is the time between B and D? Is that delta T or 2 delta T? 2, good job. So 2 delta T. That is the velocity of speed, okay? And minus VB. Minus VB. So VB again is the average velocity between A and C. So it's 4 plus 16. Over the time interval, which is 2 delta T, so it's 2 times 1 over T. Okay? So please simplify it by yourself. Okay. Okay, let's simplify together. 2 times 1 over 10 equals to 1 over 5. Here, also 1 over 5. So let's combine these two. So 1 over 5 becomes 5 here. Times what? This is 44 minus 20. 44 minus 20. So now you get 1,200. So what is the unit? Don't forget the unit is so important. For this one, it's centimeter per second. Centimeter per second. And this one is second. So at last, it's like this. But in our question, it says, please write that in meter per second squared. So we have to divide it by 100. So it becomes this. Okay? Which is the hardest problem in example 1. It says, when the object is at point A, what is the direction of its velocity? Okay, so now we can calculate VA. If we can calculate VA, then we the direction, okay? So now let's use the equation. V equals to V0 plus 18. Okay. And VA, which is beside VB, right? So it equals to VB plus 1. What is the acceleration? And what is the time interval? I think you can insert because A is here, delta T is there. Okay. You can insert by yourself. Okay, a small question for you. This distance from A to D is greater, and greater, right? So a question for you. Which direction did the car go? Did it go to the left-hand side or did it go to the right-hand side? Which will make these kind of dots. Want to try to guess, try to explain. You, yeah. I want to know your name. Wait for me. Why don't you have the paper? You don't have that? Okay. Do you want to try to guess? Like, which side does the car go? It goes to the left-hand side or it goes to the right-hand side. So it will make a dot like that. Yeah, you could translate that. Everyone, you have to think of it. It's an interesting question. If I'm the teacher who is in charge of the college entrance exam, I will ask this problem. This car, I can only grab this kind of car. Do you think the car goes here, go down the slope, or the car is here? Left or right? Right. That's right. Really? Okay, everyone, you have to raise your hand, okay? Because the camera is there. Who agree that the car goes to the right hand side? Please raise your hand. Who agree that the car goes to the left? Please raise your hand. Okay, those who didn't raise your hand, you, okay, cheer up. Okay, yes, it goes to the left-hand side. Okay, tell me, hi. Why? Why does the car go to the left? The distance come closer. Yeah. But this one is closer. Why is the car go left side? Yeah. Can you explain a little bit more? Like, if it goes to the left-hand side, which side the dot goes first? A or D? Because the timer is like dot, 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 dot. So if we go to the left-hand side, so A should be the first or D should be the first? A is the first, yes. So this is the original one, okay? And this is the final dot. So the speed becomes greater and greater and greater, right? Good job. This is an interesting question, okay? Good, but I think we can go back. So, any idea? For final velocity, in fact, I should write B or A. Like this one. In fact, A is the original speed. B is the final speed. Okay? So V equals to V0 plus AT. Okay? And then A is top. And then T is 1/10 right? And VA is what we want to know. And VB, I think you have calculated. Where is VB? Here. 5 times 20, which is 100 centimeters per second, which is 1 meter per second. Okay? So now we derive the final speed of A, which is 1 minus 1.2, right? So we get negative 0.2. What does that mean? Can anyone tell me? The velocity is negative. What does that mean? What does that mean? Yes. For others, the velocity is positive, positive, and positive. But for the first dot, its velocity becomes negative. That is, it goes to the opposite side. Okay? The opposite direction. Okay? Yeah. So number 3, the answer is negative 0.2 meter per second. So it's opposite direction. Okay? Good job. We finished 1.4. We finished 1.4. Okay. Are you all tired? Or energetic? Tired? Okay. 好，我们 take a break。没有啦，take 不是叫你们 take a break，是说我们英文先讲到这里。先问一下，刚才从今天到昨天的整个英文上课，你可以懂7成以上的道理是什么？太棒了吧？那你懂的，在5成以下的，你觉得英文太难了，5成以下的举手。
3成以下有。
3成以下，真的假的？好，其实大部分同学，你们只要能听2组北高中，你是绝对可以的。你知道为什么我要英文上课？
可以不用英文上课。
因为这次我去澳洲进行就是双语的，就是培训之后啊，我遇到了几位台湾的学生，他们到澳洲皇家墨尔本理工大学去念书。你们知道有听过澳洲皇家墨尔本理工大学的手？没有，它是全世界第43名的学校，比台大还要前面很多很多。那我在里面遇到了2个台湾的学生， 那一个是台中的达人女中毕业的，有听过达人女中吗？好，她呢也跟大家一样，她并不是特别念什么双语班呢，还是国际班，都不是哦。可是他们的老师从头到尾就像我们一样，全部是用台湾的教材，可是上课全英文。结果你知道最后他们班多棒吗？就是2/3的同学是在台湾升学，1/3的同学直接到他们最想要去的学校。其中一位他有申请上哈佛大学，对，他说就是因为他为什么敢出去申请，为什么他就是国外可能愿意，就是让他就是可以申请到那个学校，因为他的听力还有口说，包括跟人家讨论数学、讨论英文、讨论物理都有办法。这个时候国外就会录取他。对，所以其实现在就是台湾想要培养新一代的你们，就是有这个国际移动力。随时不管是外面的国家同学来台湾，你可以跟他聊历史、聊物理、聊科学、聊任何文化都好。当你出去国外的时候，你也不会什么话都不敢讲，会说 Hello, how are you 之类的。好，这就是台湾现在希望培养你们成为的方向，而且未来你们也会很勇敢，觉得你就是可以到国外念书。好，所以目的是这样。那以后的课呢，我大概就是上一半，不会像现在全部英文啊，就是尽量可以融入一些英文。你知道为什么吗？就是我之前毕业的学长姐就会回来说，老师，我真的很感谢你之前会补充一些英文给我们，因为我们现在大学不管是普物、普化、普生还是什么微积分，全英文哎。可是以前其他老师都没有帮我们补充，我们现在觉得很痛苦。可是当我们那时候高中有些学过这个，我现在就觉得天哪，我不会很害怕这样子。所以他们就跟我说，老师你一定要给学弟妹就是有这样子的一个英文的概念，然后他们以后念大学就不会那么辛苦这样子。好，这是学长姐就是给大家的一个建议。OK， 好，那这样可以哦。这样休息够了吗？我们现在2分钟哎，可以让我记一点点1至5吗？可以吧，可以吧。好，1至5很简单，这就是一个自由落体运动。OK， 那 in English called free fall motion， 自由落体运动。好，我今天带来一个从澳洲买来的球。好，那请问一下 ，What is the definition of 自由落体运动 ？What is the definition? Is this one a free fall motion? Yes? How about this one? Is that a free fall motion? In fact, yes. Okay. If the force acting on the object is only the gravitational force, if the force is only gravitational force, 重力, then we call this motion a free fall motion. Okay? Okay, we will stop here. And then please bring this book back to your home. And then we have to hand in 1.1 to 1.4 on Monday. Okay? See you.